If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip. The question we're working on today is, a particle moves according to a law of motion, S of t equals t to the third minus 9t squared plus 24t, for t greater than or equal to 0. A. Find the velocity at time t. B. What is the velocity after 3 seconds or 5 seconds? C. When is the particle at rest? D. When is the particle moving forward? E. Find the total distance traveled during the first 8 seconds. F. Find the acceleration at time t. G. When is the particle speeding up? When is it slowing down? So the position function of our particle is t to the third minus 9t squared plus 24t. To find its velocity, we just want to take the derivative of the position function. So we get 3t squared minus 18t plus 24. What is the velocity after 3 or 5 seconds? That's just plugging in 3 for t, and then we'll plug in 5 for t and simplify. So when you evaluate at t equals 3, you get negative 3, and when you evaluate at t equals 5, you get 9. To find when the particle is at rest, we just need to find when the velocity is equal to 0. So we set our velocity equal to 0 and solve. And in this case, we could factor, and we see that the velocity is 0 when t equals 2 and 4. To find when the particle is moving forward, we want to find when the velocity is positive. So we'll take our number line and break it up at the spots when our velocity is 0, and then we'll test values on each of those subintervals. And so we could see that our velocity is positive between 0 and 2 and positive between 4 and infinity. So our particle is moving forwards on those intervals. To find the distance traveled in the first 8 seconds, we want to figure out how far did we travel forwards at first, and then we change direction, so we got to figure out how far did we travel backwards, plus how far did we travel forwards. And we add up all these absolute values. So we plug in into our position function these different t values, and then we'll simplify this. So it works out to be 20 plus 4 plus 112, which is 136. To find the acceleration, we just take the derivative of velocity. And to figure out when our particle is speeding up, we want the acceleration and velocity to have the same sign. So they're either both positive or both negative. And our particle slows down when they have opposite signs. So we'll take our number line and break it up when our velocity is 0 or our acceleration is 0, and check to see what happens to our velocity and acceleration in each part of the number line. So we could see it's speeding up between 2 and 3 and 4 and infinity because they have the same sign. And it's slowing down between 0 and 2 and 3 and 4. Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.